Alright, welcome back. Here I wanted to go over just a couple quick examples using scientific notation to solve some application problems. So the first one I have says that light travels at 3 times 10 to the 10th centimeters per second. So how many centimeters per minute is that, and then how many per hour? So one thing that we have to remember is we have to remember your time conversions. So we have 60 minutes equals 1 hour, and we have 60 seconds equals 1 minute. We have to use that idea in order to do this problem. So first and foremost, I have 3.0 times 10 to the 10th, and we said that this was centimeters per second. And we need to multiply this by 60 seconds per minute. And that is going to give us how much is in it. Well, one thing that we can do is we already know that we could interchange my 60 seconds, which would end up being 6 times 10 to the first. And so here what we're actually looking at is we are looking at doing 3.0 times 10 to the 10th, and we're going to multiply that by 6.0 times 10 to the first. And because my seconds are going to go away, that's going to leave me with centimeters per minute. So here the rule again says that we have to do 3.0 times my 6.0, and this is going to be times 10 to the first, or 10th, and then 10 to the first. So here 3 times 6, this is going to give me 18.0, and this is times 10 to the 11th. And then of course 18 does not fall in proper scientific notation, so we have to take this decimal point here that we have, and we actually have to move it. So my proper notation becomes 1.8 times 10 to the 12th centimeters per minute. And so this would be the first calculation we have. Now the other one that we said we had to do was we had to do per hour. So again, we are starting with 3.0 times 10 to the 10th, and this was centimeters per second. So we have to multiply this by 60 seconds per minute, and that means multiply that by 60 minutes per hour. So if you look or pay attention, notice my seconds are going to go away, my minutes are going to go away, and this is going to leave me with centimeters per hour. Now both of these again have to change, so we're looking at 3.0 times 10 to the 10th times, we got to take my decimal and move it, 6.0 times 10 to the first, times, got to do the same thing, take my decimal and move it, 6.0 times 10 to the first. My overall units again are going to be centimeters per hour. So here we have to do the same thing. We got to multiply our numbers, so this becomes 3.0 times 6.0 times 6.0, and then we've got 10 to the 10th, 10 to the first, 10 to the first centimeters per hour. So here we're going to have 3 times 6 times 6 So that's going to give us 108 times 10, and this is going to be 10, 11, 12, so this is 10 to the 12th centimeters per hour. And then just like before, this is not scientific notation. So my decimal point here has to move, so we got to move it once, we got to move it twice. So my overall answer is going to become 1.08 times 10. We moved it twice, so I have to add 2. So this is going to be 12 plus the 2 additional centimeters per hour. In other words, 1.08 times 10 to the 14th centimeters per hour. And of course we could keep going depending on what unit you wanted to use, but this would be the second one that we were looking for. Alright, now the last one I wanted to look at reads that a light year is the distance light travels in 1 year. Find the length of a light year in scientific notation if light travels 186,000 miles per second. So the first thing we need to do is we need to take this 186,000 and we need to convert it into scientific notation. So again, my decimal point would be at the end, so we need to move it 1, 2, 3, 4, 5. So this here would be 1.86 times 10 to the 5th, and this is miles per second. Now, the first thing that we know is we're starting out with the 1.86 times 10 to the 5th miles per second, and we have to multiply that by something. Well, first of all, we are talking about traveling in 1 year. I have miles per second here. So in order to do that, it says the first thing I need to look at is that I have 60 seconds per minute. I also know that I have 60 minutes per hour. I know that there are 24 hours in a day. And I know that there are 365 days in a year. If I take a look at all of that, notice my seconds will cancel, the minutes will cancel, the hours will cancel, the days will cancel, and leaves me with miles per year, which is going to give me a light year. Now with each of these we have to change them into their own scientific notation. So here my decimal point moves once, makes this 6.0 times 10 to the 1st. Again, I gotta move my decimal point, so again 6.0 times 10 to the 1st. I gotta move it, so this becomes 2.4 times 10 to the 1st. And here I gotta move it once, not twice. Becomes 3.65 times 10 to the 2nd. So what we're actually looking at here is we are looking at 1.86 times 10 to the 5th times 6.0 times 10 to the 1st times 6.0 times 10 to the 1st times 2.4 times 10 to the 1st times 3.65 times 10 to the 2nd. So we have to take all of my numbers and multiply them together. So this becomes 1.86 times 6.0 times 6.0 times 2.4 times 3.65. And then we have to do scientific notation. So we have all of these 10 to these, which is my scientific notation. So this is times 10 to the 5th, 10 to the 1st, 10 to the 1st, 10 to the 1st, and 10 to the 2nd. So here we're going to do 1.86 times 6 times 6 times 2.4 times 3.65. And that's going to give us 586.5696 times 10 to the 5 plus 1 plus 1 plus 1 plus 2. So we've got 586.5696 times 10 to the 5, 6, 7, 8, 9, 10. So times 10 to the 10th. Now here we are looking at miles per year. Now the other thing that we need to keep in mind is we need to keep in mind that this is not scientific notation, so I need to move this once, twice. So this becomes 5.865696 times 10 to the 10 plus 2. So my overall result is the 5.865696 times 10 to the 12th, and this was miles per year. And this would be my overall answer. Now the other way that you could write your answer would have been, instead of saying per year, if you would have said light years. And the reason you could call it light years is because of your definition in the beginning, is that a light year is a distance traveled in 1 year. Since we're talking about miles per year, we're talking about a distance traveled in 1 year. So the other way you could have labeled that would have been to say light years. Alright, if you have any questions, please let me know. Otherwise, those are two different examples of being able to use scientific notation with a real-world application. If you have any questions, let me know. Otherwise, keep smiling, enjoy yourself, and I'll see you next time.